Hey everybody, welcome back to week 2 of our distance enrichment that we are doing during this quarantine period. Today we are going to look at the 2018 Calc BC exam. This is question number 4 that was actually guest starred on the Calculus AB exam also, which means some of you may actually recognize this question. It's about the height of a tree. Now, for space purposes, I left the actual questions off, but you have your books with you, so you need to look at it. It's a non-calculator question. It's your classic table question, so we can kind of reasonably anticipate certain questions are going to show up, like they're probably going to have us do a Riemann sum at some point or something. Let's just hit it. It says the height of a tree at time t is given by a twice differentiable function, h, where h of t is measured in meters, and t is measured in years. Selected values of h of t are given in the table above. It says, use the data in the table for part A. Use the data in the table to estimate h prime of 6 using correct units. Interpret the meaning of h prime of 6 in the context of the problem. Okay, we've been down this road before, so if I'm going to find out h prime of 6, I want to squeeze him in between two times that are readily known. My guess is 7 and 5. Those are the closest that I'm going to be able to use. And so we know how this movie goes. It's going to be h of 7 minus h of 5 over 7 minus 5. That's going to be a 2 right there. H of 7 is 11, so 11 minus 6, so 5 over 2. Cool. So we got h prime of 6. That is our estimation. Now we're not done yet. It says we have to now interpret this in the context of the problem. So what does this really mean? Well, because h is measuring the height of the tree in meters, we could then say the height, and I'll go and move him to about right there, the height of the tree is changing at a rate of 5 over 2, looks like meters per year, when t is equal to 6 years. And I think that's a pretty good interpretation of part A. That's a pretty good solving for part A. Let's take a look at part B. Part B says, explain why there must be a time between 2 and 10 such that h prime of t is equal to 2. Well, if they're asking me to do that, that sounds like a mean value theorem problem right there. They're asking me to show that during a certain interval, my slope was a particular value, which is basically what mean value theorem says. It says that as long as a function is continuous and differentiable on a certain interval, there will be a point in time when the average rate of change will be equal to the instant rate of change. So in this case, this is probably the first time I've ever seen them do this before, where they actually don't have the interval be the points that you plug in. A lot of people fell for it if they did h of 10 minus h of 2 over 10 minus 2. They did not end up getting 2, which really freaked a lot of people out. And I feel like some people kind of got this problem wrong because they didn't see that happen. Every other FRQ we've encountered has always had that be a recurring theme, where you just kind of plug in the numbers that they gave to you, and then and then it all kind of worked out. I am going to apply mean value theorem on this problem, though. It's just not going to be at those numbers that I was expecting. But before I do that, I'm going to say h is twice differentiable. I think I spelled that right. On the interval 2 to 10. Okay, so from here, this is mean value theorem, but backwards. So they're actually giving me that the instantaneous rate of change is 2. So from here, what I'm looking for is an average rate of change of 2. But remember, I just tried it out on 2 to 10. It's just not going to be where this lies. And so I have to find something that's going to help me get within that range. So I have a sneaking suspicion that if I do any combination of like 11 and 2, like if I do 11 minus 2, that's not going to get me a 2, because I need something that's going to divide out to become a 2. So my best bet, I'm looking at 2 things that subtract to be an even number here, and 2 things that subtract to become an even number here. So I'm suspecting that it's going to be h of 5 minus h of 3 over 5 minus 3. Well, what is that? It's going to be 2 down here, and then this is going to be 4. Oh, cool. So that's going to be 2. So, since we have found the interval in question, we can say, therefore, by MVT, oops, not MCT, MVT, there exists a time on 2 to 10 where h prime of t would be equal to 2. And that's really all we need to do for that problem there. So again, it's like MVT in reverse, making sure that we found that average rate of change. Now again, the thing that made this problem hard was that usually you expect the interval to be actually the times that you physically plug in. Every other FRQ that we've had with MVT has always kind of had that motif in it. This time they decided to put the numbers inside the actual interval, which is something I've never seen before, so just be on the lookout for that. Let's move on to Part C. Part C is asking us to use a trapezoidal sum with 4 subintervals to approximate the average height of the tree. Operative word here being average. Average, I hear 1 over b minus a times an integral. So from here, that's going to be 1 over 10 minus 2 times an integral from 2 to 10 of h of t dt. Well, what is that going to equal? Well, that's going to be a trapezoidal sum right there. So I think I'm going to go and just do my trapezoidal sum down here. Now, I like to graph. Some people don't need it. I do. So a 2 is going to be 1.5 here. A 3 is going to be a 2 here. A 5 is going to get me a 6. A 7 is going to get me 11. Pretty cool. I like that. 10 is going to get me to 15. And I'm going to go and just trapezoid this thing out. So I feel like that's my first trapezoid. That's my second trapezoid. That's my third trapezoid. And that's my fourth trapezoid. Very cool. So from here, what is this going to look like? Well, this is going to look like 1 over 8. That's my average value piece right there. 1 over 8 times, well, the area of a trapezoid is 1/2 height and then base 1 plus base 2. You guys already know that. So it's going to be 1/2. My first one is height, and then base 1 plus base 2 is going to be 1.5 plus 2. And then 1/2 height, which is going to be 2. Base 1 plus base 2, which is going to be 2 plus 6. And then 1/2 times the height, which is going to be 2. And then base 1 plus base 2 is 6 plus 11. And then 1/2 height, which is going to be 3. And then base 1 plus base 2, so 11 plus 15. Now, after all that mumbo-jumbo is all hashed out and solved, you are going to get 263 over 32. And I just decided to shortcut that one just to save us all time. Okay, let's go and take a look at Part D. Okay, so I just had to clean up the board a little bit. I was running out of space. Part D, it says the height of the tree in meters can also be modeled by a function g given by g of x is equal to that thing. So from here, with Part D, g of x is equal to 100x over 1 plus x, where x is the diameter of the base of the tree in meters. When the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of 0.03 meters per year. At that point, you should have told me to stop reading, because I'm suspecting that dx over dt is equal to 0.03. And as we are all BC students now, I think we kind of see where this might be going. This is very obviously a related rate problem. According to the model, what is the rate of change of the height of the tree with respect to time in meters per year when the tree is 50 meters tall? Okay. Sorry, I got tripped up there. So basically, they want us to find the derivative with respect to time, and then find out what g prime of x with respect to time is going to be. So how do I do that? Well, g prime of x is going to be a couple things. I got a little bit of quotient rule in my life, and a little bit of implicit diff by my side. So what I've got is I've got low, and then d high will be 100 dx dt minus high, which is 100x. D low is going to be, the derivative of 1 is still 0, the derivative of x is dx dt, and then I'm going to square the bottom, and we're going to get ready to rock and roll. So from here, we already know that dx dt is 0.03. The problem is I don't know what x is. However, it is saying that when the tree is 50 meters tall. So what they're saying is they know that g of x at some point will equal 50. So I just got to solve for x when that's true. So that's going to be 100x over 1 plus x. Kick him over, so 50 times 1 plus x equals 100x. Kick off those two, 1 plus x is equal to, looks like 2x. So x equals 1. So I can plug all that mumbo jumbo in. So it looks like I'm going to get 2, and then times 100 times 0.03 minus 100 times 1 times 0.03 all over 2 squared. So what does all this mean? This is going to become a 3, so 3 times 2 is 6. This is going to become a 3, so minus 3 over 4. I am getting 3/4. Now, it seems like they're not asking for me for units, but if we want to put it in there, we could say then that the tree's height is changing at a rate of 3/4 meters per year when it is 50 meters tall. And again, I don't think they asked for that justification, but it's always cool to plug it in. Okay, it's pretty easy FRQ. It should be a bit of a review for you guys. We'll come back and we'll hit some more FRQs in another video. And I hope you guys are staying well and healthy. See you all later.